Okay, I'm going to be talking about how to write formulas using ions, and these are all going to be for ionic bonds. So before we get started, just as a reminder, on the periodic table there are things called cations and also things called anions. And if you take a look, the things on the left-hand side of the periodic table are going to be the cations, so these are going to be all the positive charges. And the things on the right-hand side of the table are going to be the negative charges, or the anions. Things that when they bond would become positive or negative. There's also things called oxidation numbers, and you should know these. These are predictions for how elements will lose or gain electrons. So everything in group 1 is going to be +1, group 2 is +2. The transition metals right here and also the intertransition metals are hard to predict. So we are not going to predict the oxidation number for those because they are so difficult. Group 13 is +3, 14 is plus or -4, 15 is a -3, -2, -1, and 0. So you should definitely know those. It's a good way if I ask you for calcium, which is in group 2, you can know its oxidation number and then know how it's going to bond. Just as a reminder, positive ions are things that have lost electrons, and negative ions are things that have gained electrons. Okay, so those are the oxidation numbers, and make sure you know them. And now we are going to use those oxidation numbers in these ions, and what we're going to do is we are going to cross the number and drop the charge, and that's what I like to say to help me kind of remember it. And I'll explain what I mean in just a second. So our first bond that we're going to do is between calcium and chlorine. And if you take a look at the oxidation numbers, like we just talked about, calcium is in group 1 on the periodic table. I'm sorry, not group 1, group 2. And so it's going to have an oxidation number of +2. So the +2 up here. Chlorine is in group 17, which is over here. So it's going to have an oxidation number of -1. So you're going to take those charges, and I'm going to rewrite my elements, calcium and chlorine. And then I'm going to do the cross the number, drop the charge. So if you imagine someone holding their hands up like a touchdown in football, and then crossing their hands like the I Dream of Jeannie kind of thing, the thing that's on the top right corner will come down to the bottom left, and that's what we're going to be doing right here. When the numbers are at the top, in other words, when they're up like this, they are going to represent a charge. When they come down to the bottom corners, they're going to be representing an amount. So the one that is next to chlorine, we're going to bring that down next to calcium. I'm going to cross the number. I'm going to leave the charge behind. And then I'm going to do the same thing with calcium. The 2 that was next to it will come down next to chlorine. Any number that is a 1 or that can be simplified, you do not have to write when you write the formula. So when I write this formula out, it's CaCl2. And that's it. What that's saying is that these were the original charges. If we bonded just one calcium and one chlorine, when those two things bonded, they would have an overall charge of +1, meaning they wouldn't be stable, they would be unhappy in some way, shape, or form. They would want to go out and bond with something else. So in order to make these stable and happy, we are going to need the calcium and the chlorine and then another chlorine in order to make that happy bond. If you take a look at this, this is what you get. So that little 2 represents the number of chlorines in our formula. Okay, so that's the first example. The next one we will do is for magnesium and sulfur. So the first thing that you're going to want to figure out is the charges on each of these atoms. Magnesium is in group 2, so its charge is going to be +2. Sulfur is in group 16, so its charge is going to be -2. And then you cross the number and drop the charge. So the 2 will come down here, and this 2 will come down here. Just like before, if there's a number 1, or if you can simplify, you don't have to write it. So since both of these numbers are 2, I don't have to write them, so I can write MGS instead. They'll cancel each other out. If I had a 2 and a 4, then it would become 1 and 2, because that simplifies. So make sure you check that each time. And then we will also do one more example, and this example will be a polyatomic ion. So calcium, and then the polyatomic ion ClO3. And if you look on a polyatomic ion's chart, it has a charge of -1. In the North Carolina reference tables, there's a list of polyatomic ions on page 7. You should be very familiar with that list. All a polyatomic ion is just an element that, or not an element, but a bond of multiple atoms that has a charge. And so this is a good example of one of those polyatomic ions. And then calcium, just like before, will have a charge of +2. So when I go to cross the charges, the 2 that is next to calcium is going to come down here, and the 1 that was next to ClO3 or chlorate is going to come down here. There's one more thing you have to do, or have to worry about when you have a polyatomic ion. If there's a number down here, that amount is going to belong to everything next door to it. So to show that, you're going to need to add parentheses. So when I write this out, it will be Ca parentheses ClO3 with a 2. And that 2 shows that it goes to everything next door. Another thing you want to make sure you're able to do is to identify the amounts of each element. So in this problem I have Ca, Cl, and O. There's no number next to calcium, which means that I have just one calcium. Next to chlorine, there is also no number. However, it is in parentheses, so I'm going to have to multiply. 1 times 2 gives me 2 chlorines, and then for oxygen, 3 times 2 gives me 6. So make sure you're able to do that. Make sure that you know about polyatomic ions, and make sure that you have the oxidation numbers memorized. Once you get good at this or get a little bit of practice, you're not going to have to draw it out like I did. You can do it all in one step. But if you're struggling with it or still trying to learn it, it's a great way to learn it.